today I am going to introduce you a topic called Boole's inequality. So, probably who may be for Boole's inequality school. Yeah. In 1854, an English mathematician, John Boole, introduced Boole's inequality. So, he wanted to find safest ways to estimate a probability without overlapping or double counting. Like, sometimes the probability double counting usually happens. So to avoid that, we found a safest way. So it states that for any finite or countable collection of events, the probability that at least one of the events occur is less than or equal to the sum of probabilities of individual events. So he introduced two inequalities. So for n number of events, like A1, A2, A3, the inequality says that probability A1 union A2 union AN will be less than or equal to the individual probabilities A1 plus A2 of AN. So if you are writing in the summation terms, you can write it as P of union I equal to 1 to n by AI is less than or equal to the summation of I equal to 1 to n P of AI. So this is the first inequality he introduced. So as I said, the inequality states that for a finite or collective set of events, the probability can be less than the probability of at least one event occur will be less than or equal to the sum of the individual probabilities of the event. So he also introduced another inequality, which we usually say probability of intersection. Here we use union. Here we are using intersection. Intersection I equal to 1 to n AI is equal to, it is greater than or equal to summation of I equal to 1 to n P of AI minus n minus 1, where n stands for the number of events. So these are the two inequalities Boole introduced. So I will tell you when these two are used. This equation is used usually when we have to find at least one of the events. Okay, at least one event is occurring. And this equation we use when we have to find the events are occurring simultaneously together. So this equation we usually call it as upper bound and this as lower bound. I will be explaining more in grade question. So the first equation is actually derived from the addition theorem which you will have explained. So what was the addition theorem for probability? P of A union B is equal to P of A B minus P of A intersection P of A intersection B. So probability can never be 0. It can either be positive or a 0, right? So if you are subtracting a term, a positive term like this from this equation, obviously we can write this equation into less than or equal to P of A plus P of B. Actually, it has a very long proof. So it has been avoided from our syllabus, so we are not discussing that. So actually, this equation is derived from the addition theorem of probability. So now we are moving to a problem. So through that we will explain more how this both equation works. So write the question. In a class of 100 students, 60 students like maths. 60 students like maths. And 50 students like physics. So the first sub-question is to find the maximum possible number of students who like at least one subject. So we have the first to find at least one subject. Number of students who like at least one subject. And the question is the number of students who like both the subjects. So we know that the total number of students is 100. So the sample space here is 100, right? And we are taking the probability of number of students who like maths. We can write it as we can take the students who like maths as A and the students who like physics as B. So the probability of students who like maths will be P of A is equal to 60 by 100 and P of B will be 50 by 100. So we can write it as 0.6 and 0.5. So now the first question, at least one of the subjects. To find it, the number of students who like at least one of the subjects. So here it is the case of at least one subject. So we have to use the first inequality, that is P of A union B is less than or equal to P of A plus P of B. So if we are using this equation, we get P of A union B would be less than or greater than 0.6 and 0.5, we get 1.1. So we know that probability can never exceed 1 and it lies between 0 and 1. So this is the upper bound of this equation. This question, but we have maximum effective set as 1. So we have to set probability A union B as 1 because it can't exceed that way. So the next question is those who like both subjects. So for that we are using the second inequality equation, that is was P of A intersection B will be greater than or equal to P of A plus P of B minus N minus 1. But the number of events here is 2. We can write the equation as P of A union B is greater than or equal to P of A plus P of B minus 1. So we will get a final answer of 1.1 minus 1, that is 0.1. So we get at least student number of students who like at least one subject. We can convert this one into number of students, like multiplying it with 100. So all students like at least one of the subjects. In the first case. In the second case, we are converting. We get it as 10 students. So the number of students who like both the subjects is 10. So what might be the difference between addition theorem and Boole's inequality? Because in addition theorem, we uses that last sentence minus P of A intersection B. But here it is not there. In that question, it will be given that where the both case occur, it will be given. But in this case, it is unknown. Let's say overlapping or double counting might happen in this. So it can be solved using Boole's inequality as we are finding the intersection. This is the both case. So we do not have any idea of where the overlapping is occurring. So we have to use Boole's inequality. So the applications of Boole's inequality include risk analysis, engineering safety, error estimation, and machine learning. So this basically helps in avoiding the overestimating of overlapping or double counting. So for that we use Boole's inequality, and it helps us to estimate probability when exact overlap between events are unknown. So as in this question also, if they didn't provide were the students like both of the subjects, they only provided that the 60 students like maths and 50 students like physics. They didn't provide who like both subjects. So we have to find that. So for that, Boole's inequality is very helpful. So more problems related to this Boole's inequality will be handled by Inequality. So any doubts? No. So hope you all understood. Thank you.